Hello everyone. I'm sorry I'm not there with you today. Here's what I'm needing you to accomplish while I'm gone. So you need to grab one of these reviews. And guys, if you take this review seriously, then you're going to do phenomenal on the quiz. And that's the second thing you're doing today. You're going to work on this review for the first half. And then for the second half of class, you're going to take the quiz. Okay? A couple of things. The answer key to the review will be at the front, so I want to see you checking your work. And then when you do the quiz, it's just the same kind of stuff. You guys are awesome. You have integrity, so you need to be keeping your eyes on your own paper, not cheating, right? You guys know this. What is the only way that you can get a 0 on a quiz? It's if you cheat. Okay, so if you need to do corrections, you need to do retakes. You know you can do that as long as you stick to your integrity. Okay, again, y'all, this review is a great representation of the quiz. So if you take this seriously, then you're going to do really good on the quiz. Okay, the quiz is on learning target number 3, which is the electrical laws and equations. We had 2 of them. We had Ohm's law, which was V equals IR. And then we had the electrical power equation, P equals IV. And then notice something, the coast method. That means that if you are not using the coast method on the quiz, you will lose points. So on this example that I'm going to show you, please make sure that you're doing all these same coast method steps: collecting, organizing, analyzing, solving, and thinking. Is that a reasonable answer or not? Okay. We know with this V equals IR and P equals IV that some of those variables made sense. Like we had voltage, and let's put the symbol. Like the symbol inside of the equation was a V, right? There's our voltage. Now, the unit for voltage was volts. Great. And the symbol was V. This one made sense. This one was great. It's after this one that we're like, wait, hold on. For example, resistance, inside the equation, it has the symbol R for resistance, okay? So right there, great. Now the unit was ohms, so there's an ohm. And then it had a symbol, which was the omega symbol. Make sure that your answers have the proper units. Okay, current was the weirdest one. So current in the equation had a symbol of I. And there it is right there. The name of its unit was amperes, or amps. And it had the, I think it was just the A for the amps, right? Because there was the microamps, yeah. Okay. Great. Now, power had the symbol P. It had units of watts. And then the symbol was a W. All right, now, I have good confirmation, because look, I just checked. Look at that A, amperes. Each calculation question that you have on the quiz, I need to see the following. So let's do this example together, and then I'm going to turn it over to you guys. An electric heater dissipates 180 watts of power. So I want to see you on the quiz. You need to underline the things that are given to you. So they're giving us how many watts of power while drawing a current of 6 amps. So we're going to underline this because they're giving that to us. And then the question goes on. It says, what is the resistance of the heater? All right, so we just collected. Now we need to organize this into a list of knowns and unknowns. So they told us that the power was 180 watts. They told us that the current was 6.0 amps, and that we are trying to figure out what the resistance is. So we've collected, now we've organized into a list of knowns and unknowns. Okay, we need to analyze. And how we're analyzing this is we're trying to pick the proper equation for this right here. So we need, and I'm going to have this on your quiz, by the way. This means that power is equal to I squared times by R, or power is equal to IV, or power is equal to V squared over R. Like that, power equals all of those things. And then we got our voltage, and then we got our resistance, and we got our current. Okay, great. We need to pick an equation that has power and current and will let us solve for resistance. So let's look at this resistance section, and we need to pick one that has power and current. And oh my goodness, guys, I put a C for current, but we know the symbol in the equation is an I. Will you fix that, please? Great. So look, this one right here, it says that resistance is equal to power divided by current squared. Now, this is the analysis. I need to analyze which equation to choose. And so we need to choose an equation where we know the items that we're plugging into the equation and that what we're solving for is the unknown. Great. So now that we've analyzed, let's solve. So I'm going to plug this into my calculator. I'm going to take 180 and divide it by 6, but this is current squared, so I need to do squared. All right, so 180 divided by 6 squared. 6,480. Okay, but what is this? 6,480. Well, we're solving for resistance, so it must be ohms of resistance. So we just solved, and then the last thing is thinking through this. And really what I want you to do here is I just want you to think, did I put my proper units here? Like, did I actually do that? And if you go, yeah, I added my proper units, then we're going to put a box around it. So, COAST method, you need to collect. Like, I'm not even kidding y'all. When we grade this quiz, when I am back, there will be points for underlining. There will be points for organizing into a list of knowns and unknowns. There will be points for analyzing, picking the correct equation, showing me that. There's going to be points for solving, and then thinking, what should my final unit be? Okay, so we have more of these kinds of questions. I'll have the key filled out. It'll be at the front. And then this is a cumulative one. All right, so we've done this kind of question, this style of question before, but it has been a minute since we've done it. How would I just quickly help you get it set up? So number 6, part A, and again, there's going to be one very similar to this on the quiz. Number 6, part A, determine the total resistance. Well, looking at this circuit, there's 3 resistors, and they are in series, not in parallel. And we know to get our total, when it's a series, we just add them together. Don't forget that the K means 1,000. So this is 3,000 ohms plus 10,000 ohms plus 5,000 ohms. Okay. So my R total is going to be 18,000 ohms. Now I have proper units there, and that's the final answer for this section, so I'm going to put a box around that. Calculate the current. Well, guess what? We know, and we just determined the total resistance, and now we're figuring out the current. We know that the resistance total, I'll put a T for total, was 18,000 ohms. And here it tells us that it has a battery and that the voltage is 9 volts. Okay? And we're going to solve for the current. Excuse me. All right, so V equals IR. We're solving for I, so I'll divide both sides by R. V divided by R equals I. Okay, so 9 volts divided by the 18,000. Okay, so this equaled 0.0005 current amperes. If you want to write it in scientific notation, you certainly don't have to, but if you do, we'd move the decimal over 1, 2, 3, 4. So this would be 5.0 times 10 to the negative 4th amps. Okay, determine the voltage across each resistor. So I'm just going to set up one of them, but there's 3 resistors, so you need to do this for the other 2. And then, of course, you can check the key. I will look at resistor 1, R1. Okay, now, R1 had a resistance of 3,000 ohms, okay? And it said that up in the diagram. The voltage of the battery, the current through this circuit is what we just barely solved for, 0.0005 amperes. And we want to look at what the voltage drop is just across this first resistor. Okay, now V equals IR, and we know the current and we know the resistance of this resistor. So current 0.005 times by the resistance 3,000, and that means that the voltage drop across this resistor was 1.5 volts. I'm going to put the little ones there again. So the voltage drop across resistor 1 was 1.5 volts. Okay, you're going to do something very similar for resistor 2 and resistor 3. The current stays the same for all of them. It's the resistance that's different. Now, we're going to find the power supplied by the battery. All right, well, we know that the voltage in the battery was 9 volts, and we know that the current of the circuit was 0.0005 amperes, and we're solving for power. Okay. P equals IV. So this is going to be our 0.0005 amps times by 9 volts. Our power is 0.0045 watts. So we'll just do a capital W instead of writing it out. Okay, determine the power dissipated by each resistor. So similar, I am going to just look at the first resistor, but then you need to do something similar for the other two. So we know the voltage drop from resistor 1 right there. Okay, so V1 was 1.5 volts. And the current across this circuit is 0.0005 amperes, and we're trying to get this P1, the power dissipated by each resistor. Okay, that's what we're solving for. And so P1 equals IV1. So 0.0005, there's our current times by that voltage drop. 0.00075 watts. Again, you could write it in scientific notation if you want. All right, and then I think you can handle part F right there. Okay, everyone, make sure, keep an eye on the clock. Make sure that you give yourself like at least 20 minutes, maybe even longer to do the quiz. Like you should be starting and working for that 20 minutes. So maybe at like when you get the 30-minute mark, it's like clean up, put everything away, and then start the quiz. Okay, you totally got this. Finish this review. Prep for the quiz, and then when you have 30 minutes left in class, get going on that quiz, and then we will grade the quiz next time.